Lesson 2.2, segment addition postulate. Segment addition postulate says this. If we have a line segment, we'll call it AC, so that means there's a starting point at A and ends at C, and a point B is somewhere within points A and C, the sum of the lengths of the segments A, B, and BC will give the total length of AC. And so that should make sense to you. So let's say AB is a distance of 3. I'm just making this up. You don't have to write it. And B to C is a distance of 7. What would the total length of this be? Picture being like a string or something you're measuring. Well, it'd be 3 plus 7, which would make it be 10. So that's all, is that the parts add up to make the whole. Number 1 says point G is on line segment FH. I will go ahead and draw that first. So let's say we have our line segment. We'll put a point here at F and the other endpoint here called H. G is somewhere in between. I'll read the rest of it to kind of see how to draw it a little bit to scale. FG, that distance is 10, and then G to H, that distance is 5. So it looks like F to G is going to be longer than what G to H is. Okay, so FG, I'll call this 10, GH is 5. Find the length of FH. So they're wanting the total length. That would be 10 plus 5, which is 15. Simple enough. Number 2. Point K is on line segment JL. Go ahead and draw segment J to L. K is somewhere in there. KL is 6 and JL is 8. Determine the length of JK. Be very careful on this one. K, we'll put it back here. K to L, that distance is 6. J to L is actually the entire segment. So this is what is 8. Determine the length of JK. So what is this? You're saying what number plus 6 would equal 8? Well, I would solve by subtracting 6. So really it's taking the whole length minus the part we know, and that means that it would be 2. Or I could say that JK equals 2. And then the only thing we add to this is make it a little more algebra based. Point M is on line segment LN. Okay, I'm not going to worry about if it's drawn to scale or not. I'm just putting M in there. LN, that's the entire segment from here to here is 3x plus 3. LM is 4x. And MN is 2x. Determine the numerical value length of MN. So we're finding this length right here. To set this up, we would say this part plus this part would be 4x plus 2x should equal the total 3x plus 3. Solve for x, we would combine our like terms. 4x plus 2x is 6x. Solve for x, I'm going to subtract 3x over here because I have to have something on this side. That would give me 3x equals 3. Divide by 3. X would be 1. But I can't stop there because it wanted an actual length. It wanted the length of MN, which is taking 2 times the x value I just found. So 2 times 1 would be 2. So MN, that length is 2. Okay, I'm going to let you pause and try number 4. First, I just have it set up. You should have your parts of 3x minus 5 plus your other part 2x minus 1 equaling the whole 3x plus 2. You want to combine like terms on the one side first. So 3x plus 2x is 5x. And then negative 5 minus 1 more would be negative 6. I'm going to subtract 3x. I'm running out of room, so I'm going to subtract 3x from 5. 5 minus 3 would be 2x. I'm adding the 6 to 2, which would be 8. Dividing by 2 would give me that x is 4. But what does it want me to find? The actual numerical length of JK, which is right here. So to find JK, I would have to take 2 times 4 minus 1, which is 8 minus 1 is 7. So the length of JK is 7.